Welcome to AP Environmental Science. In this video, we are going to talk a little bit about indoor air pollution. Now, before you freak out, there are things that we can do to reduce indoor air pollution, and we will talk about some of those strategies in this video. Now, indoor air pollution has two main sources. They can be anthropogenic in nature, or human-caused, or they can be natural. And I'd like you to take a moment and look at this image and think about whether or not that pollution is from an anthropogenic or a natural source. Now, some of the anthropogenic sources include asbestos, which is found in some types of insulation, and from other insulation that is not asbestos related. Anthropogenic sources also include formaldehyde, lead, volatile organic hydrocarbons, or VOCs. Remember, those are things that evaporate at room temperature. And anthropogenic sources of indoor air pollution also include smoke, and that smoke would be from combustion of various sources. Natural indoor air pollution comes from dust, mold, and radon. Now, these are things that exist without humans coming in and interfering. However, humans can create this indoor environment that allows things such as mold to flourish, and that becomes a greater problem. Now again, I want to zoom in on a few of the anthropogenic sources. We'll discuss a few here in this slide and a few more in subsequent slides. Anthropogenic sources include insulation, and insulation is typically these tiny glass fibers. And if they become airborne and you inhale those tiny glass fibers, those can wreak havoc on your respiratory system, causing all sorts of tiny little cuts. Now, insulation could also contain asbestos. However, asbestos is no longer used as an insulation in the United States. However, in older homes, you may still have insulation around some pipes and other fixtures. That insulation containing asbestos is fine as long as it stays in place. If you are doing any kind of remodeling and you're going to disturb that asbestos, that is when you need to be concerned, because that is when that asbestos can become airborne. Volatile organic compounds, or volatile organic hydrocarbons, also are another anthropogenic source. These are typically found in things like furniture, paneling and carpets, cleaning supplies, fabric softeners, dryer sheets. Typically, volatile organic compounds, they're going to have a bit of a scent to them. Formaldehyde is also found indoors. Now, formaldehyde sounds like this big scary chemical, and it does do a lot of harm. But the reason why we find it inside is to try and preserve certain types of building materials. So a lot of the wood that is used in home construction is treated lumber. And that means it's treated with some kind of chemical. It might be formaldehyde, it might be a different chemical. And that particular chemical prevents the wood from rotting prematurely, which helps build these strong structures that are not going to rot away. However, a lot of the chemicals that are used in that treating process can slowly emit back into the home. And you can't talk about sources of indoor pollution without talking about lead. Now again, lead is no longer used in paint. It's no longer used in gasoline. However, lead in older homes might be in some of those older layers of paint in the wall. So you need to be particularly careful to make sure that the lead paint is being covered and not being disturbed. So if that lead is disturbed, then it can become airborne, and that's when you start to inhale it, and that's when it becomes an issue. Again, I want to zoom in here a little bit on asbestos. Now, asbestos is a natural mineral that's composed of these tiny thin fibers, and it was used as insulation in a lot of buildings prior to the 1980s. By the 1980s, it had been completely phased out, and we were no longer using it in new constructions. However, it still exists in older buildings. Now again, removing that asbestos can create these airborne particles, and if those airborne particles are inhaled, that can lead to a lot of respiratory issues, in particular mesothelioma, which is a type of lung cancer. Combustion is often coming from using small engines or stoves or lanterns or grills or cook stoves or fireplaces, vehicles, even smoking. Those all release smoke into the atmosphere. Now, if you are doing combustion indoors of any type, you are going to be releasing carbon monoxide, you're going to release nitrogen oxides, you're going to release sulfur dioxide, you're going to release particulates, and if you're burning tobacco, that tobacco smoke is also being released. So a whole host of air pollutants are being released from combustion. Again, some of these outputs depend on the type of fuel that's being used. However, no combustion indoors is going to be without air pollution. Carbon monoxide is one of those pollutants from combustion, and carbon monoxide is an asphyxiant. So an asphyxiant basically suffocates somebody, meaning that it reduces your body's ability to carry oxygen throughout the body. Remember, your cells require oxygen in order to do cellular respiration and turn that food into actual usable cellular energy. So what happens is the carbon monoxide reacts with the hemoglobin in your blood and prevents that hemoglobin from being able to carry oxygen. Now, some of the symptoms of carbon monoxide poisoning would be dizziness, nausea, and suffocation. Oftentimes, people will pass out before they truly suffocate. So it's a peaceful death, but it's still a preventable death. Mold and dust are some of the natural sources of indoor air pollution. Now, mold is primarily growing in places that are humid, they don't have a lot of circulation moving through there, and often is due to water leaks that are allowing this mold growth. Now, a lot of people are allergic to mold and dust and pollen, and this can cause a lot of respiratory irritation. Particularly, it can cause asthma and allergies. Often, if you're exposed to a lot of mold, even if you're not allergic to it, you can experience headache and fatigue. Dust also contains particulate matters, and those particulates can lead to all sorts of respiratory issues, as we discussed in a previous video. However, dust can be controlled. So you can put filters on your heating and cooling systems that are moving a lot of the air throughout your home, and those filters can help remove a lot of that dust. In terms of preventing mold, you can make sure that you don't have leaky pipes. You can make sure to use a dehumidifier during the summertime to reduce the amount of humidity in your home. Radon is a radioactive gas, and radon is an indoor air pollutant that we have to worry about in certain parts of the country based on that bedrock geology of that region. Now, radon is naturally occurring, and it's produced by the decay of uranium that's found in rocks and soils. Now, the reason why radon's dangerous is because it has a very short half-life, meaning that emits a fair amount of radiation. So that radon moves up through the soil and enters homes through cracks in the foundation or in those basement walls, and it also can enter homes through groundwater. I want you to take a moment and look at these images on this slide, or perhaps even pause the video and sketch them into your notes. You need to know how radon can get into your home. Once radon gets into your home, it can cause some serious health impacts. In fact, radon is the #1 cause of cancer deaths in terms of an environmental influence. It is the #2 cause of lung cancer deaths. And this is all because that radon is seeping into the home and people are inhaling this and not even knowing it. I want you to again look at this diagram on the left-hand side of your screen. You can see that radon is inhaled through the nose and mouth, and that radiation is actually going to damage your lung tissue. So it gets at your lungs from the inside instead of that radiation attacking from the outside. But there is something you can do about this. you can test your home for the presence of radon, and you can install a radon mitigation system. Now, the word mitigation means to reduce the impact of something. So some things that you can do to reduce that risk of exposure to radon would be sealing any cracks in the foundation or walls of the basement. And you can also use what's called a slab suction system, or this radon mitigation system, and that is what is diagrammed on the right-hand side of your screen. So what happens is you insert a pipe down underneath the foundation of the home, and there's a bit of a fan in there that sucks the air from under the home and pumps it out above the house. So this allows that radon gas to really bypass the house, and it follows that path of least resistance. So it's going to go through the pipe instead of going into the home. Briefly, I want to talk a little bit about sick building syndrome. Now, if you have a lot of these indoor air pollutants and you have a very highly insulated building, there's very little ventilation, little air loss, this can lead to an accumulation of these air pollutants inside of the structure, and that can lead to eye and throat irritation, headache, dizziness, nausea, difficulty breathing, and all of these health impacts from that increased exposure to indoor air pollutants. Now, in summary, and I know this was a lot of information, and feel free to send me questions here for any clarification. You need to be able to identify natural and anthropogenic sources of indoor air pollution, and you need to be able to describe some of the health impacts associated with those indoor air pollutants. Again, in this diagram, this lists some of the many sources of indoor air pollution. You should be able to identify some of these on your own without having to look at the diagram, or be able to make your own diagram in your notes. Please send me your questions here at the end, and I hope that as you watch this video, you were able to learn something.